All right, new Octave, a Matlab-like open source scientific computing. And I've been using this for more than a decade, off and on. Not much lately, but I used it extensively some 7 years ago. Okay, full disclosure. Much of the text of this presentation came from a local open web UI AI machine, namely mine. I utilized a large language model using GPT-OSS, the 20 billion parameter model, as well as in some portions the Dolphin Mixtral 8 by 22 billion model. Some of the content came from the World Wide Web, of course, and very little from my head. So,
I'm an honest man.
Why do that if I'm supposed to know this stuff? Well, as I've always said, I'm a lazy programmer, and I'll spend hours figuring out the hard way, that is, making the local AI work properly, when the quicker path may have been a whole lot easier. Well, I also wanted to see how good the LLMs are in my local AI. That was the real reason. And since it worked, creating good, or you might call it bad presentations, these things can get a little easier in the future. Okay. How good was the AI? Well, let's go through the presentation and see the live demo. The live demo, of course, is not AI. So it created all of this for me and says, what is Octave? Well, it's a free open source alternative to the commercial Matlab program. It's an interpreted programming language for numerical computations. It has a very high compatibility, about 95% with Matlab syntax and functions. And because it's a Berkeley style license, it works on Linux, Mac OS, Windows. What are the origins of Octave? Well, the project actually began around 1988. It was first intended to be a companion to a chemical reactor design course. And the full development was started by John Eaton in 1992, and I've shown you where I got that information from. Octave Levenspiel is a former professor of the in college, and he's the author of this book, Chemical Reaction Engineering. It was a reference book that I was using. There was another one, I think it was McCabe and Smith, I forget, which I actually used, but this was a reference book. And I think, Catherine, you might find this of interest. You're a chemical engineer.
She left.
No, she's around. She stepped out.
Oh, she just stepped out. Okay.
She left her computer.
Okay.
Oh, okay.
So Levenspiel apparently was known for his ability to perform quick back-of-the-envelope calculations, as was my professor, Joseph Bertie. I did meet with John Eaton at OctConf in 2014 in Montreal, Canada. And we had some great discussions. I made a presentation there, and I'll talk about it subsequently. So being a chemical engineer, knowing that I wanted to do complex calculations, it was the ideal tool. Why use Octave? Well, cost. 0 license fee. It's open source. Transparent, modifiable, community-driven, still being actively supported by John Eaton and some other magnificent supporters that I met in Montreal 11 years ago, sorry. It's cross-platform, and the same code runs on any of these operating systems. It has built-in packages. It has MATLAB tool compatibility. So if you have MATLAB code that you can find on the Matlab website. Very often you can just copy and paste it and it will work. And it's a great tool for teaching, you know, in colleges, schools, etc. Of course, Matlab is also offered for free for educational purposes, but the best part of Octave is you can use it for anything.
Oh,
Commercial or non-commercial.
free probably.
Was there a question? Sorry.
Oh, did you say Matlab is free for academic uses?
A limited version, I believe. That might have
Yes, you can get, I have MATLAB free for academic use, but University of Dayton buys a license.
Huh.
So free is a relative term.
Yeah,
free is a relevant, yeah, exactly. Relative term.
thank you.
That's how it all works. It's free.
So why did I use Octave? Well, I wanted to use it to design a better propane burner. And it was used, and the purpose was a recreational vehicle refrigerator. So here you will notice that this is a generic design of an ejector, gas ejector, where you're mixing the primary fuel coming in from the left in the small nozzle with a larger opening for air that comes in through the intake here. And the Venturi effect will entrain the air, cause mixing of the gaseous fuel along with air to be ejected out through this flare. Principles of a rocket engine, except you don't use liquid oxygen here, you use just plain air. So I happened to find a dissertation, and I've shown the page by this gentleman, Liao. He had done all of the fundamental science behind how to model such a gas ejector. And best of all, it had the full Matlab source code. So I picked it up and said, okay, since it has the source code and it was written in Matlab, can I duplicate everything that he had done in Octave? And surprisingly, yes. It produced every calculation, every graph to the very almost last one. To illustrate how complex your calculations can be, I just happened to pick out this equation 3.32 from page 37 of this thesis. You look at this and you're going, oh my gosh, this is not easy. And this is not just one equation. This dissertation has several, tens of such equations. So what are the core features? It's interactive, command line. You can do it through a GUI, or you can just write text MATLAB-like code and execute it on the command line. Best of all, it's a matrix-centric language with vectorized operations. What does that mean? You can literally define A as a matrix and B as a matrix and say A multiplied by B, give me the matrix result.
Okay.
Its extensive built-in mathematical functions are very, very good. Now, those of us who get into control theory and so on will probably deal with things like Laplace transforms. If you're dealing with sound analysis, you'll be doing Fourier transforms. If you want to do control theory and say, I want the inverse Laplace transforms and so on, this thing can do it. There was only one limitation, that it could only do a first order, not a second order Laplace inverse transform. Plotting. It's very similar to Matlab's plot. You can literally just lift Matlab's plotting instructions and it'll work. It is capable of file input output, text, binary, Excel, HDFS, etc. Sorry, HDF5, etc. It has support for custom functions. It is object oriented, and there are numerous packages you can load, just like Python. So how do you get started? Very simple. Sudo apt install Octave if you're running Ubuntu. And then I've shown the other command lines. If it is Windows, you'd have to download an MSI file from the official website. So you can run it two ways. You just run Octave on the command line, and you get a Python-like interface. You type your commands. Or you can say Octave -- desktop, and you get a GUI, much like you would in any IDE type of environment. Here's a simple script. A percentage is a comment, so therefore that first line is just a comment, hello.m. And something like print is basically display, and you're saying hello Octave. And you can run this with, having saved it as hello.m, you can say Octave space hello.m, and it'll execute it on the command line. Some examples of syntax. When I talked about matrix multiplication, here you've got a 2 by 2 matrix A, where you have 1 and 2 on the first row, 3 and 4 on the second row. Or you can have something like defining X, give me a random number 3-element column vector. So random being the function. I'm kind of going through this pretty rapidly. Let me pause here for any questions. Okay, I take it there are none. Good. So, basic syntax, some more examples. If you had defined A previously as a square matrix, a 2 by 2, and you say B equals A plus 5, now you're doing a scalar add on every element of the matrix A. You could define C equals a dot-wise multiplication, or you could do a classic matrix product. Very simple syntax. No looping to be done, nothing. All of that's taken care of in the background. And by the way, this works on integers, real numbers, imaginary numbers, complex numbers. I mean, this is phenomenal. If you want to particularly pick out an element from that matrix, you could say, I want to pick from the second row, the first column, and that's the syntax for it. Or you could say, give me the whole first row. So you're saying 1 comma, and then you put the colon. Or the whole second column, for example. Those are examples of addressing and extracting values from a matrix. You can do loops if you want to. You could say, hey, calculate if the determinant of that matrix A is greater than 0, which means that matrix A is positive definite. Otherwise, it prints, well, hey, it's not positive definite. And what is a determinant? I've shown basically a determinant is in a simple 2 by 2, an A, B, C, D means you are doing A multiplied by the value in D, or whatever is D, subtracting from that the product of B and C, It's almost a cross multiplication and a difference of the cross multiplication, which is a determinant. If you want to plot, you can define x starting from 0 and in increments of 0.1 going up to 2 pi. Simple definition. And then you say, okay, y equals sine of x, and then you plot it and you get a sine wave. If you want to plot in 3D, a little more complex, but you can do it. Let's talk about the packages. So there are community-maintained extensions for statistics, signal processing, bioinformatics, etc. How do you install it? Well, you just say package install -forge and whatever is the package name. I didn't use this method because I tend to use the Puritan method of installing stuff in Ubuntu. Basically sudo apt install, and then you find the appropriate package that
to a standard recognized method.
Sorry about that.
Can I stop and ask a question?
Sure.
certainly.
What is PKG? I'm not familiar with that. Command.
You know what? I really don't know the answer, but I can look it up for you since I didn't use it.
Oh, I just didn't know if I was missing, like everyone knew this other non-apt. Okay. If no one knows, yeah, then that's good.
Sorry, I don't know it.
It's using the BSDs use PKG.
Oh, yeah, it's a BSD package installation
Oh,
utility. Okay, but
Good, thank you.
Yeah, Kumar says he used sudo apt install.
yeah.
right.
But it's interesting that it provides. Maybe I thought you were on BSD.
Similarly, if you have Matlab libraries or files, you can just load those files directly out and it will work out of the box. So you can go to the Matlab blog sites and say, hey, has somebody done something like this? Well, whatever, and I just copy paste from there and it just most of the time works. So here are some examples. You would start out by installing Octave and the associated documentation. I have Octave control. I have Octave instrument control, which means it can acquire information from data acquisition cards, etc. Octave I/O, which can do file I/O, etc. There's Octave Signal, which means if you want to do signal processing, and particularly either fast Fourier transform or inverse fast Fourier transforms. Octave Data Smoothing, which I have utilized, but I have not used Octave Sockets. I have played around a little bit with Octave Financial, but I really don't have much use for it. Certainly, I don't know what's in Octave General, but I've certainly used Octave Strings. I have not used geometry, nor structure. Certainly tried out symbolic. It's pretty good. And I have definitely tried out Octave Video as well as image. I have played around with Octave optimization, but not extensively, and I don't use statistics. Now, there used to be some packages that were available, and I'm a little saddened by not seeing Octave Zenity. And ODE package was really good, but what they've done is some of the functions of ordinary differential equations, they have ported it into core Octave. Therefore, I'm okay with that. My thesis itself had a lot to do with ODEs or ordinary differential equations, and not anymore, but it's a really good tool. I'll put some references up there. And of course, you can go to John Eaton's own website and you can download stuff from there. There are lots of mailing lists and all kinds of help. And of course, the nicest part of it, because it's so much of it is compatible with Matlab, you just could ask people Matlab-like questions and you can then utilize it here in Octave. And I'll stop over here before I go into the live demo. Any questions?
You know, you might have touched on this and I just missed it. The ability to make an executable like you do in Matlab, where it makes a pseudo executable, it really just combines scripts and the runtime.
No, I never attempted that.
Okay.
I didn't need to, because execution speed in my case was not really critical. When I was, one of the applications I used this for, which is the talk that I gave in Octave conference in 2014, was utilizing CoolProp, which is what I mentioned in my summary of this particular talk. CoolProp is the equivalent of RefProp, or refrigeration properties, that is published by NIST, the National Institute of Standards and Testing. So because the recreational vehicle refrigerator, which is really a chemical plant, the processes are so slow that my response time from doing all the thermal, the mass balance, the thermal balance, and the energy balance calculations, if they were done in even 5-second intervals, that was fast enough. Because the refrigeration cooling process itself takes so many hours to reach from ambient to saying it can produce ice in the ice box. And my whole project was instrumenting the RV refrigerator. By the way, it's an ammonia absorption refrigeration cycle. No moving parts whatsoever. And it works on heat. You apply heat to get cooling. It's amazing. How do you do that? Well, you have to look at the simple analogy that I teach people when I talk about ammonia absorption refrigeration. Where do you think your electricity comes from? Coal? Natural gas? Nuclear? Or steam from the ground? Or the sun? Well, all of the sources are thermal. Cut out the middleman, and can I get cooling by using heating? Bingo, it works. So, because it's a chemical process and largely based on diffusion of gases and vapors and so on, the process was slow enough that making it an executable was not necessary. So I've dodged the answer. Maybe somebody has done it, but I didn't explore it. I certainly have taken Python code and converted it to executable because I needed the speed. But then again, it's nothing like writing C programs and seeing it run much faster. So there's always a trade-off. Hopefully I've answered your question. Sort of. The answer is I don't know. Any other questions?
You actually build them on your refrigeration system, or you just model it?
Well, oh, I was working for Norcold in Sydney. We were making the refrigerators.
Oh, okay.
Yeah, it's pretty neat technology. I mean, it evolved. Actually, Albert Einstein had written papers on it, and subsequently, Platten and Munters, a couple of guys in Europe, took it further and perfected it. And the surprising part of it is it uses hydrogen as well as ammonia and water, and these are the three basic chemicals that are necessary. Of course, there are other chemicals in it to prevent corrosion inside the tubes, etc., etc., but it has no moving parts. You can run it with a propane flame, or you can actually run it with any kind of flame that you can get. It can be a kerosene lamp, it can be, and therefore, in very remote parts of the world, you can provide refrigeration with almost any fuel source. So we were building.
Propane was a big one too.
Pardon me?
Propane, isn't that used too for that?
Yeah, I mean, predominantly the RV uses propane because in the cooler latitudes, propane is used. Whereas when you start getting into the tropics, it is butane, because you've got to be accounting for the prevalent temperature and therefore what is the fuel that you need to utilize that will remain a liquid in the warmer conditions. So in India, actually, they use a lot of butane because butane has a higher boiling point than propane. So you have to alter the jets and so on and so forth in order to make it work. But the refrigerators we were building, you could have a tri-mode, which is it could run on 110 volts, or it could run on 12 volts, which is what the RVs run on. If you wanted, optionally, you could get a 24-volt DC system. And of course, you could get a propane version. Now, you would ask the question, why don't you use a regular refrigerator? Well, the prime reason is no moving parts. The regular refrigerators, when you're on the road, will not last because of the vibration inputs to the oscillating type of compressors that are used in most household refrigerators that are stationary. They just can't take that kind of abuse. That's the reason for using one with no moving parts. Most household refrigerators are based on an oscillating pump. And many of them are run with an inverter technology, whereby you can do soft start and modulation of how much the thing oscillates back and forth. It's almost like a steam locomotive, correct? Think of it as there's a piston and a cylinder, and on either side of the cylinder, the piston compresses the gas, and you're oscillating it with a frequency superimposed on it that's making that thing shuttle back and forth. There are, of course, the larger ones that are scroll compressors, and there are, nutating type disc compressors and so on, but those are more for the commercial kind of large scale industrial refrigeration. Most of the household refrigerators are designed to be the oscillating piston. So beyond just the demonstration of Linux and open source, I kind of love to talk about engineering too. Any questions? All right, so I'm going to move this off to the side and slide in this. Sorry, I may not be, let me see if I can change the font. Maybe, may not be.
It's big enough.
Well, big enough for us.
It's big enough? Okay. All right.
Fine.
So here's a comment, hello.m. I'm in the GUI version of Octave. Therefore, you have all the look and feel of an IDE with all the benefits of command history, the ability to explore and display variables, and how, if you're looping, how they change and all of that. So I've got that simple command out here. Hello, Octave. Let me pick up some sample code from what I had illustrated before. So we're going to create an array, a matrix. So here's what I've defined. Done. I say A and hit enter, and there it is. 1 and 2 in the first row, 3 and 4 in the second row. Let's take something like what I had illustrated before. Give me a random number. What is X? I just type X and it tells me right there it is. So I asked it for 3 rows, single column, and there it is, random numbers. Okay, so now I'm going to say arithmetic. Add 5 to every value of A. And there's B. 1 plus 5, 2 plus 5, etc. So now that we have A and X defined, let's do an element-wise multiplication. As simple as that. Oh. Oh. And this is deliberate, by the way. What we are trying to do is multiply a 2 by 2 with a 1 by 3, and it's saying, I can't do that. They are not conformant. So it also realizes that, hey, you can't do stupid stuff like that. Now let's try this here. Define D. Same thing, even the multiplication. So you would have to necessarily now say, hey, I either have to modify A or I have to reduce my X. So let's take this over here. I'll copy that. Paste it here. Now I say 2. And then I take this over here. Okay. What is C? Now it works. So imagine that you have to do very large arrays. And let's say you have an array that is really representative of an image. Say 1024 by 768, 3 colors. So you've got 3 matrices, each representing the red, RYB, red, yellow, blue. And you want to do a color transform, or you want to do a shading transform. Well, behind all of that is really this matrix operation. That's why I say that the image package, which is available with Octave, is really mathematical operations, and therefore you can manipulate images. I'll pause here for any questions. Good so far? Anything else you would like me to illustrate? You get the gist of it, correct?
I think I'm seeing heads nodding.
Good.
Oh, I have a quick question.
Sure, go ahead.
When saving out data in Matlab, like if you were to go to your workspace and then right click on A and then say save in Matlab, it would save it out as a .mat file. What's the equivalent file type, or is there that capability to save out data in Octave?
I think you would use the IO. I really don't know the answer. So what you're saying is you want to save the matrix A by itself somewhere.
Correct.
Is that what you want to do?
Yes, or any, so like the software I have that I manage at work, it's completely MATLAB, and there's a ton of we generate a ton of 3D imagery, and we save that. The application saves it out as a .mat file, but we had to write our own H5 writer, and I was just wondering what the equivalent is here.
I really don't know the answer, but how I would do it is probably export it as a CSV.
Okay.
because A is a matrix. I would probably export it as a CSV. And then I can import it whenever I need it. It is not storage efficient, I concede that. But I will have to look into it because I have not really utilized such a feature or needed one, excuse me. But I'll look into it.
No, I can look into it more. Thank you.
Any other questions? All right, so that is the end of my presentation. Questions, comments, or rewards are welcome.
Have you ever used Sage?
I have played around with it, but I didn't really adopt it. It's similarly quite extensive and very, very capable.
I like Octave better than Sage still, though. I've used them both, and Octave seems to make a lot more sense to me most of the time.
You got it.
Vectors and make linear algebra.
Linear algebra, exactly. And that's why I tried Sage and I said, you know what? There's so much more. Of course, Sage is very mature. There's a big audience and user community for Sage. But to me, what appealed was the Matlab-like compatibility and my personal familiarity with Matlab. And therefore, I said, okay, Octave's the alternative. Any other comments? Good. Thank you all. Appreciate your time. Hope you found it useful.
Yeah, it was.